So let's spend a few minutes getting reacquainted with the coordinate plane. The coordinate plane is a two-dimensional world in which we can plot points that are represented with ordered pairs, an x-coordinate and a y-coordinate. And those points can ultimately be used to graph lines or other types of graphs, but for our purposes, just linear equations, so lines. So we should quickly review that a coordinate plane is made up of an intersection of this horizontal axis, we call that the x-axis, and this vertical axis referred to as the y-axis. Now where those two axes meet is right there, and that's referred to as the origin. It's basically where we originate from to plot all other points. And the origin, when you think of its ordered pair of its x-coordinate and its y-coordinate, is made up of the ordered pair 0, 0. So as we start to finish labeling this coordinate plane, we want to recognize that now the x-axis and the y-axis make up these four sections. These are called quadrants, and these quadrants are numbered with Roman numerals, and we always start in the upper right and we move in a counterclockwise direction. So this first quadrant is referred to as 1, with the Roman numeral 1, and moving around counterclockwise, we have quadrant 2, quadrant 3. In quadrant 4, we just want to make sure we remember as a Roman numeral is written as IV, not I. So we break this pattern, and that's just the way the Roman numerals are written. So the next thing that we'll finish out before we move on with the bottom part of those notes is to remember how ordered pairs, remember an ordered pair is made up of a coordinate for x, the horizontal location of a point, and a coordinate for y, the vertical location for a point. We just want to quickly remember how those points are constructed for each quadrant. So if we're in quadrant 1 from the origin, we're moving to the right, so that's considered a positive direction. But then we're turning going up, and that's also considered as positive. So any ordered pair in quadrant 1 would be made up of a positive value for x and a positive value for y. If I go back to the origin again and I'm looking to move to the left, well, for an x-coordinate, that would imply a negative. But while still moving up, that's going to imply a positive for y. So in the case of quadrant 2, starting at the origin, I'm moving left, negative, while moving up, positive. Those would be the types of ordered pairs I would be bound to have for a quadrant 2 from my coordinates. If you continue around, then you can see that for quadrant 3, we're still moving in the left direction for x, but now we're moving down for y. So if moving up was positive, then moving down must be negative. And likewise for our final ordered pair in quadrant 4, or construction of ordered pairs in quadrant 4, I'm once again moving to the right, just as I was in quadrant 1. But now I am moving down, so there. I'm moving with a negative y value. So that should be enough information to help you in plotting the points and labeling them. Make sure you plot the points based on their ordered pairs, not forgetting that the first value is your x, the second value is your y, but then labeling as A, B, C, D, E, or F. And likewise, when you get here, without plotting, being able to identify what quadrant or axis, because sometimes a point is not falling in that empty space. So we want to know that if it's not in a quadrant, it's probably sitting in an axis. And a giveaway for that is you're going to see zeros showing up. And this one, as we know, is a special point. So I'll let you work on that, and we will review the answers to what you plotted and what you identified for locations when you come back to class. But the last problem I want us to focus on is right here. These can be a little confusing at times. So what I like to do is, first of all, draw a little coordinate plane, and I like to mark where I'm being told this ordered pair, generically speaking, AB falls. It's in quadrant 2. So we know AB is going to be right there. And because of that, I'm going to know that my A value, representing the x coordinate, must be negative, while my B value, representing my y coordinate, must be positive. So I'm going to make a further note of that. I'm going to say that A is negative, and I'm going to make a note that B is positive, because that must be true to make this ordered pair fall within quadrant 2, because A is my x, negative, B is my y, positive, to land me in quadrant 2. As long as I know that, then I can rearrange or manipulate these values in any way to create new ordered pairs. And that is what is being asked here. So notice my B value is now going to play the role of x. My A value, after some manipulating of it, is going to play the role of y. So let's think about that. If my B is positive, playing the role of x, then my x is now going to be a positive value. So there's my B. It's going to be positive. Now my A value on its own right there was negative, but we want to recognize that there's that oppositizer sign there. So it's really saying it's the opposite of a negative. So when I'm done with an ordered pair constructed as B negative A, is going to ultimately translate into a positive combination, because the opposite of a negative is a positive, and that's going to ultimately land me in quadrant 1, because we know that's where ordered pairs of a positive and a positive reside. So those are slightly higher level thinking questions. I want you to take this as a model and finish this problem, and then there will be some additional problems for you to answer beyond that. We'll check in class. If you have any questions at that point, we'll cover them.